In today's video, we will learn about metallurgy. So, the entire chemical and technological process employed for the extraction of metal from its ore is known as metallurgy. The metallurgical process for the extraction of metal depends upon the nature of metal and its ore, right? Since metal have different chemical and physical properties, they require different method for their extraction. Thus, there are no common method for the extraction of all the metals, but there are some common steps that involves in almost all the metallurgical operations. These steps are: first, the concentration of different types of ore of different metals; second, the extraction of metal from its concentrated ore; after that, the metal that is extracted being refined or purified in the third step. Let us take a look on it. The first step is the conversion of ore, or we can say that the concentration of ore. The mined ore are invariably contaminated with rocky, sandy, and earthy particles. The unwanted impurities of rock, matter, and sand, etc., in ore are known as gangues or the matrix. The process of removal of this impurity or the gangue is known as the concentration of ore or the beneficiation of ore. Now here big lumps of ore are first broken into small pieces by means of mechanical crushers. The crushed ore is then grounded to a fine powder in a ball mill. Now the process used for removing the gangues from the ore is based upon the physical and chemical properties of impurities and the ore. That means we separate the ore from the gangue on the basis of the chemical properties of ore or the physical properties of ore. The method that we use is the first, the gravity separation. This gravity separation method is corely based on the density of gangues and ore particles. Here, this method is employed on those ore where the ore particles are heavier than the gangues, right? In this, they are washed in a water current. After that, what happens? The heavier ore particles settle down on the bottom and the gangues washed away like this in the water current. Second method is the froth flotation method. Now, the froth flotation is used for the enrichment or the concentration of sulfide ores. This method is based upon the principle that gangues, that means the impurities, are wetted by water, whereas the ore particles are wetted by the pine oil. Here, the powdered ore is mixed with water and some pine oil. The mixture is vigorously aggregated by passing compressed air to produce froth. You can see here in the representation. Here we mix the ore in the water and the pine oil. After that, we apply compressed air through this pipe. What happens after that? The gangues that are wetted by the water settle down on the bottom and they are removed from this, and on continuous centrifugation the ore particles that are wetted by the pine oil get up with the froth, right? And this is how we concentrate this ore and filter this ore and dried it for the further steps. Now moving ahead on conversion of ore into its metal oxide. So for conversion of ore into its metal oxide, we classify ores into two different categories. The first is the sulfide ore, then we have the carbonate ore. So for carbonate ores, we use the process that is calcination. In calcination, we heat the ore in the absence or the limited supply of air, or we can say that oxygen. After that, what happens? The carbonate or the hydrated ore get converted into its oxide and carbon dioxide. Here, no supply, or we can say that limited supply of air is happening. So by this, we convert these carbonate ore of calcium, magnesium and zinc into their respective oxides, and carbon dioxide is released in this process. Now, for the sulfide ore, we use roasting, right? In roasting, what happens? We heat the ore in excess of air, or we can say that in the presence of oxygen. After that, what happens? The sulfide ore, for example here zinc sulfide, gets converted into zinc oxide and sulfur dioxide gas is released in this case during roasting. So here we employ calcination and roasting for the conversion of carbonate and sulfide ore into their respective oxides, right? Now, after converting the metal sulfide and carbonates into oxide, we will reduce this metal oxide into pure metals, right? Now for this, the metals of low reactivity, we will do simple heating of that metal oxide to get the metal. So what happens in this process? Now the metals low in the activity series are not very reactive. The oxides of this metal can be reduced to metal by heating them alone. For example, cinnabar, that is the sulfide ore of mercury, when heated in air is first converted into oxide of mercury and then reduced to mercury itself. That means the strong heating of low reactivity metals oxide will result in the formation of or the extraction of that metal from the oxide. Here we can also understand through this flow chart where metals of low reactivity, when present in the form of sulfide ore, they are simply roasted. After roasting, they are converted into oxide, and further heating of their oxide, we get the metal. After that, we will simply refine that metal. Second example is the extraction of copper. Copper is also a quite low active metal, right? It is obtained from the sulfide ore of copper, that is the copper glance, that is Cu2s. It is obtained by simply heating in the air. When we simply heat copper glance or the copper sulfide into the presence of oxygen, it will first convert it into copper oxide and sulfur dioxide gas, and further heating of this copper oxide will result in the formation of copper metal and again sulfur dioxide gas. Now, metals of medium reactivity. The metals in the middle of the reactivity series such as iron, zinc, lead are moderately reactive, and they are reduced from their oxides to their metal by using some reducing agent like coke. Coke is nothing but the purest form of carbon, right? So here take an example. If we have zinc oxide, right? Zinc oxide is a mediumly reactive metal, that is zinc. Now here we use carbon, that is in the form of coke. This carbon will reduce this zinc oxide into zinc and will form carbon monoxide. In the same manner, we reduce some middle reactivity metals like lead and iron by using carbon as a reducing agent. By simply heating in the presence of carbon, it will convert it into metal and carbon monoxide, and in case of iron, it will convert it into iron and carbon dioxide. Now, moving ahead, this is the flowchart representation of how the medium reactivity metals are reduced. First, their carbonate or sulfide ores are converted into metal oxide by calcination and roasting. After that, this metal oxides undergo reduction in the presence of carbon, right? By which we get extracted metal. Beside using carbon to reduce metal oxide to metals, some displacement reactions also used. For example, the highly reactive metals like sodium, calcium, aluminium are used as a reducing agent. In case of manganese oxide and chromium oxide, we use aluminium as a reducing agent that converts these oxide into pure metals like manganese and chromium in molten or liquid state, and here aluminum oxide is formed in both the cases. These both reactions are highly exothermic as large amount of heat is produced in these reactions, and the metals are present in liquid, or we can say that they are molten state. Now, when a mixture of ferric oxide, that is Fe2O3, and aluminium powder is ignite, the iron obtained is in molten state. Therefore, the process is used to join railway tracks and crack machinery parts. So the reaction of this process will be iron oxide when reacts with aluminium will form molten iron that will used in the fulfillment of the cracks or the welding of railway tracks. And here large amount of heat is also produced. Here reduction of metal oxide by aluminium powder in which large amount of heat is evolved is known as the thermite process. Now metals of high reactivity. The metals which are high up in the reactivity series are very reactive as these metals are highly electropositive. They cannot be obtained from their compounds by reduction with carbon. This is because these metals are themselves very strong reducing agent. So these metals are obtained from their ore by the electrolysis. So simply electrolysis of NaCl will result in the formation of sodium metal, right? So for highly reactive metals, we use electrolysis process. Similarly, aluminum is also obtained from molten aluminum by electrolysis at the cathode, right? So I hope this topic is now clear to you.